To our understanding, that this Hyperlayer data project is the first instance of its kind where so many data layers are being collected for the same chunk of land or the same chunks of land within the Olds College Smart Farm. It's the first time that's being collected, all those layers together in the right scale, at the right resolution, in the right format to allow machine learning and computer systems to crunch through that data, to connect dots that have never been connected before, or to identify relationships that have never been identified before, because the data's typically always been collected, I don't want to say haphazardly, but not in a consistent way or a deliberate way to develop basically these training data sets. So that's really the value of the Hyperlayer data set that we're building at Olds College. And when others have heard about kind of what's included in this data set and how it's being developed and how it's available for use to develop new algorithms, it's been described by industry stakeholders as an exquisite data set, and it's been described as probably the most digitized piece of soil in Canada, if not North America or the world, because of the number of data points and data layers that we have collected for field 15, 16 on the Olds College Smart Farm. It's an important one with respect to data and figuring out how to utilize the data that is now becoming easier and easier to collect on farm, how to turn that into actionable insights or information that farmers can use, and information that technology developers and industry can use to develop new tools and new algorithms for things like yield prediction or understanding available soil nutrients and all of these other really critical aspects of crop production that really can be data driven. We're collecting all these layers so that we can figure out which ones are most important to predict yield or to predict available soil nutrients in the subsequent year. So that then that baseline information, or that basic information, or minimal information, I should say, can be collected on farm at each farm to help them make decisions for their specific field. The lows are mostly related to pandemic and the whole delay and struggle with growing the team at Olds College. But this one definitely has some highs with respect to the college's profile. And like I said, people are now looking to Olds College and specifically this project and saying, "Holy man! Like no one's ever done this before. This is really unique, and we want to be a part of it." And one of the other really valuable highs for me as someone who's interested in training the next generation of experts, I guess, is that this project has led us to a relationship with McGill University and the training of a PhD student at Olds College. So as a college, obviously we don't offer PhD programming, but we can partner with universities to have students do the coursework at the university, and then they're doing their field work and data collection on the Olds College Smart Farm. So we are supporting the training of a PhD student as part of this project, which is tremendously exciting for me and has opened the door for probably at least one or two other PhD students who are now interested in working with the Smart Farm for their program. It's been mind blowing, I guess. So first of all, having a relationship with a university like McGill for this project is really great as well. But this particular PhD student is so he has a very broad network. He's actually from Brazil. He did his master's in the US. So in addition to working specifically on the Hyperlayer data project, he has contacts and he has connections with almost every technology provider that we're working with on the smart farm, even outside of Hyperlayer data. So he's very well connected, and he's been working with Dr. Melnichuk, and I believe they have discovered some IP protectable tools or technologies or algorithms that will be going through some IP or patenting processes here in the near future. And that happened within his first 8 months at Olds College. So it's just tremendously exciting to watch that kind of progression and development. But this project wouldn't be happening without CAAIN support. It'd be happening in some sort of capacity, but not nearly at the scale and at the level that it currently is, and would be getting obviously the interest and the outreach from other stakeholders and industry enthusiasts. We wouldn't be able to be building, I guess, the platform that we are building without the CAAIN support. And again, this was another really obvious fit with the overall umbrella or mandate of CAAIN on the digitization of ag. So we're covering smart farms, we're covering automation in ag, we're covering digitization in ag in these three separate projects. And it's just highlights this tremendous relationship between CAAIN and what the smart farm is really built to do. CAAIN has been basically my entire life at Olds College. On day 2 of my employment at Olds College, I was thrown into an all-day meeting with Cornelia Kreplin and Jason Bradley to talk about, what can we submit, or what can Alberta Innovates and Olds College work together to submit to this ISED call for proposals. So ever since day 2 at Olds College on January 8th, 2019, I have been I guess, involved in first the development of CAAIN, and then the submission of 3 proposals to CAAIN, and now managing and leading three CAAIN projects. So my my journey at Olds College has been intricately linked with CAAIN. So I have, basically my career at Olds College to thank for CAAIN.